Hi future scientists, I am Atom, and in this video we will learn how to convert a position time graph to a velocity time graph. So let us create a position time graph and a velocity time graph for this scenario, Mole's day of skateboarding adventure. First, let us represent each segment of Mole's journey on a position versus time graph. Mole skateboards from her house to the library, which is 4 kilometers away, and arrives there in 1 hour. Here is the position time graph for this segment of the journey in blue. At the library, Mole spends 2 hours studying. Here is the position time graph for this segment of the journey in magenta. Then Mole travels further for half hour to a cafe 3 kilometers away to get lunch. Here is the position time graph for this segment of the journey in red. She spends 1 hour at the cafe enjoying her sandwich and tea. Here is the position time graph for this segment of the journey in green. On her way back home, Mole meets up with her friends Isaac and Valence at the city park, which is 4 kilometers from the cafe, and it takes her 1 hour to reach the park. Here is the DT graph for this segment of the journey in black. At the park, Mole plays basketball with her friends for half hour. Here is the DT graph for this segment of the journey in orange. Finally, Mole skateboards back home, covering a distance of 3 kilometers in 1 hour. Here is the DT graph for this segment of the journey in teal. Now let us convert this position time graph to a velocity time graph. Step 1 is to mark the different segments of the journey with dashed vertical lines on the time axis. Step 2 is to calculate the slope for each segment of the journey. The slope of each segment gives us her velocity, since velocity is equal to displacement divided by time interval, delta d over delta t. There are 7 segments in her journey. Slope of segment 1 equals positive 4 kilometer divided by 1 hour, which equals positive 4 kilometer per hour. Slope of segment 2 is 0 kilometer per hour. Because she's at rest, it's a horizontal line. Slope of segment 3 is plus 3 kilometer divided by half hour, which equals positive 6 kilometer per hour. Slope of segment 4 is 0 kilometer per hour because she's at rest. Slope of segment 5 is negative 4 kilometer per hour because the delta D here equals 3 kilometers minus 7 kilometers because final position minus starting position. So that equals negative 4 kilometers divided by the 1 hour, so negative 4 kilometer per hour. Slope of segment 6 is 0 kilometer per hour because she's at rest. Slope of segment 7 equals negative 3 kilometer per hour because the delta D here equals 0 kilometer minus 3 kilometer. So that's negative 3 kilometers divided by the 1 hour equals negative 3 kilometer per hour. Now that we have calculated the velocities for each segment of our journey, now let us set up the axes for the velocity time graph. So that will be our step 3. Step 4 is going to be marking the different segments of the journey on the time axis exactly like we did for the position versus time graph. Step 5 is to draw the velocity graph for each segment based on the velocity value which is calculated. So segment 1 equals plus 4 kilometer per hour. So draw a horizontal line for plus 4 kilometer per hour in segment 1. And for segment 2, it is 0 kilometer per hour, so you'll just draw a horizontal line on the time axis. Segment 3, draw a horizontal line for plus 6 kilometer per hour. For segment 4, draw a horizontal line on the time axis, indicating the velocity is 0 kilometer per hour. For segment 5, draw a horizontal line at negative 4 kilometer per hour. For segment 6, draw a horizontal line on the time axis, indicating velocity is 0 kilometer per hour. For segment 7, draw a horizontal line at negative 3 kilometer per hour. So that will be our VT graph, which is derived from the DT graph. There you have it, converting DT graph to a VT graph made easy and fun. Please subscribe, like, share, and comment for more fun science. Happy learning! Thank you.